What are you doing, Seth?
Well, I was just sitting here thinking about how to pronounce our new acronym, PDVDS.
You mean the levels of Patreon support?
Yeah, I can't figure out whether it's pot TV dus or pativadus. I mean, either one would kind of sound right to me.
Well, I think you need a vowel in there to pronounce it. It might just be easier to say protozoa, tardigrade, velociraptor, dolphin, space explorer.
Yeah, but that misses the whole point of an acronym. You know, what does radar stand for? Radio distance and ranging or something? Much easier to say radar.
Again, radar has a vowel in it. Well, while you're pondering how to pronounce PTVDS, we hope that listeners will go to the Patreon page and become a P, a T, a V, a D, or an S. For a small donation, you could become a protozoa, a tardigrade, a little bit more, a velociraptor, but whatever amount that you give, you help keep Big Picture Science in production.
Exactly. And no matter which level, listeners who donate on Patreon will get a reward as thanks for their support.
That's right. Go to patreon.com/bigpicturescience, choose a level, and join us. If you become a protozoan, the P in Seth's acronym, you can get access to exclusive polls.
Or give a little more to become a tardigrade and get Patreon exclusive bonus material, which I recommend.
And anyone who joins can hear each new episode early and ad-free and free of us struggling to pronounce the acronym PTVDS.
I think I'm going to use it at my next cocktail party. Patreon.com/Big Picture Science. And thanks for your support.
No one's having cocktail parties anymore, Seth. Thank you.
Forget the meaning of life. What's the reason for it? Well, we can give you one answer by going old school, and nothing is older than the rocks. The exposed sedimentary layers in the Grand Canyon are as much as 1.8 billion years old, and there are rocks in Greenland that are twice as ancient. And since rocks record the past, we turn to geology to help us explain how we got from there to here. And I'm here, and I'm Seth Shostak.
I'm Molly Bentley. Welcome to Big Picture Science, produced at the SETI Institute, where researchers investigate the nature and origin of life. On Big Picture Science, we step back to get the wide-angle view on science and technology, and in this episode, we rock on with geology. From how the physical composition and topography of the planet defined trade routes, provided a home for the Roman Empire, and created restrictive island habitats that limited evolutionary options. And if you doubt that, just ask the dodo. And now human activity is sufficiently changing the planet to warrant a new geologic age, one incorporating the Greek name for human, the Anthropocene. How will we continue to shape Earth's future and our own fate? It's Geology is Destiny.
A number of highly improbable events led up to you being right here, right now. For an historian, a chronicle of those events might include the development of agriculture, the rise and fall of empires, the industrial and technological revolutions, and the origin of the route of the number 51 bus that ferried you across town.
Geologist and historical scientist Walter Alvarez offers a wider perspective, one that encompasses deep space and time, and that explains how we happen to even be on this planet, a small rock hurtling through the cosmos. In other words, his purview is 4 billion years of Earth's history.
Dr. Alvarez, who along with his father Luis developed the impact theory of dinosaur extinction in the 1980s, is interested in big history, from the Big Bang to the forces of continental drift to the appearance of low-lying topography in northern New York State that facilitated the growth of the U.S., Dr. Alvarez has geologic explanations for the appearance of life on this planet and why we are where we are right now.
A Most Improbable Journey is Dr. Alvarez's book, A Big History of Our Planet and Ourselves.
Like so many people, I love history. I love reading history just for pleasure and for understanding the human situation that we find ourselves in. But unlike most people, I'm also interested in the history of the Earth and how it has influenced the human world that we live in. So most people, in thinking about history, would take the physical world just as the stage on which human history has unfolded. But for me, Earth history is its own interesting subject. And by looking at those rocks, we can find out what happened in the past, because rocks remember the past. And so that's what we're doing out there with those hammers. We're breaking off pieces of rock that will tell us about things that happened in the past, which in turn have influenced the world we live in today.
Well, let me take a specific example. You take a train ride in the book, or you describe one, in which you go from New York to the Midwest and on further eventually. And out of New York, you don't go directly west towards Chicago. You go north, up the river, up the Hudson River, and then eventually you make a left turn where the Erie Canal was, and you go through kind of a flat spot between the mountains that line the east coast. And you point out that if that flat spot wasn't there, New York might not be New York, the East Coast, the Midwest, the whole history might have been different.
Yeah, that's a wonderful example. The Erie Canal played such an important role in the development of our country in the early 19th century. You know, right after the Revolutionary War, people like George Washington were really worried that the United States was just this set of former colonies that were trapped between the Atlantic Ocean and the Appalachian Mountains. And Washington was worried that it might be the French or the English or the Spanish who would colonize or build and develop the area west of the Appalachian Mountains, and that would thoroughly trap the United States in that coastal strip. And so they searched for the best way to get across the mountains, and it turned out to be by going up the Hudson River, which itself is a wonderful river. It was scoured out by glaciers, and it's tidal, so the tides will help carry your boat up, and so you could get up to Albany real easily. And then they found that they could turn left, as you say, and follow the route of what became the Erie Canal and get as far as Buffalo and on to the Midwest. And so that really opened up the center of what is now the United States to the people who lived in those former 13 colonies.
So, in other words, this flat spot allowed easy communication from, well, New York, really, and the whole East Coast, since New York is on the water, all the way to the Midwest, to the Great Lakes, so that they could use the lakes for further transportation. But why was this flat spot there? I'm from Virginia, and there's a wall of mountains that separate where I am from Ohio, for example, and there's no easy way across them if you're just trying to dig a canal. What is it that accounted for the fact that we have this flat spot up in upper New York State?
Well, your mountains in Virginia, the Blue Ridge, are folded mountains. It's as if the layers of rock there, sedimentary rock, had been pushed like pushing a rug across the floor, and they'd been folded up into a long series of folds. That's what the Blue Ridge are part of that. But as you go north up through Pennsylvania, and once you get into western New York State, that all has been pushed up by the rise of the Adirondack Mountains in northern New York State, and there's a kind of a saddle between the two, and that's where the Erie Canal goes. So it's really there as a result of the geological history that built the Appalachians.
What about the river systems of the Midwest? We have the Missouri and the Mississippi systems, and they've funneled lots of smaller rivers down to the Gulf of Mexico and so forth. And that was really important in the early development of the United States. Was it just convenient, or was that essential in your view?
Well, let me quote from a friend of mine, Steve Dutch, who's a geologist in Green Bay, and he's made a really interesting point, which is that if the last ice age had had less ice than it did, in other words, if it hadn't been so cold and built up such big ice sheets in Canada, then the Ohio River and the Missouri River would not have followed the lines that they follow now. They might be way up north in Canada. And in that case, there would not be the Ohio River, which is what really opened up the middle of the continent to the Americans.
Well, crossing the Atlantic and going back a little bit in time, let's go back to Europe for a moment. In the late 16th century, in 1588, in which the Spanish Armada is defeated. Now, I always figured that was the intrepid nature of the British Navy, but apparently geology played an important role here.
Well, in the first place, the whole point of the Armada was for the Spanish army, which was in what's now Belgium, to be transported over to England, which had become Protestant because Henry VIII wanted to divorce one of his wives, right? So the Spanish wanted to bring England back to Catholicism, and they were going to have to transport their army across the English Channel. And if the Ice Age had been different, there might not have been an English Channel there, and the army could have just walked into England. But they were going to have to transport their army from Belgium to England, and the English were trying to stop them. And one night in 1588, as the Armada was anchored just offshore of Belgium, the wind happened to be blowing towards the land. And so the English set fire to some old ships and let the wind blow them into where the Armada was anchored. And they so completely confused and disorganized the Armada that it was basically the end of that attempt to invade England. And so that's why English is spoken in California as well as Spanish.
I like studying a little bit of ancient history, in particular Roman history. Is there some geological reason why Italy is Italy and therefore Rome could be Rome?
There certainly is. It's very dependent on Earth history. And the reason is something that you can see if you look at a map of the Western Mediterranean. You'll see that between Spain on the west and Italy on the east, there are the two islands of Corsica and Sardinia, which are aligned north-south. Well, we now know from geological evidence that those islands used to be up against the coast of France. And maybe 25 million years ago, something like that, they rotated away from France to their present position. And as they did, they collided with a submarine plateau, which was not above sea level, but the collision pushed it up above sea level. And that made the Apennine Mountains, which are the backbone of Italy. And that's why Italy is there. So without that rotation of those two islands, there would have been no Italy and no Rome for you to be interested in, and no Catholic Church and no Renaissance. So that's a pretty big deal in terms of what Earth history has done to influence our world.
Walter, as an astronomer, I sometimes get accused of being a low-grade physicist. I can't really argue against the low-grade part, but I kind of wonder in geology whether you don't confront the same sort of thing where people say, look, geology, I mean, it's just chemistry. It's no more than chemistry. Or maybe a little biology thrown in when you have sedimentary rock or something.
Well, Seth, I get the same sort of thing that you get. Geology is not usually ranked up high on the list of sciences along with physics and chemistry. But I think there's a really important point to make, and that is that physics and chemistry are what I think of as process sciences. In other words, they tell us what can happen. Physics tells you that things will fall down, they're not going to fall up. So those two sciences tell you what can happen. But there are other sciences which I think of as historical sciences, and they tell us what did happen. And that would include astronomy, it would include geology, it would include biology and archaeology and several others. So those are the sciences that, for me, as somebody who finds history fascinating, are the most interesting.
I'm going to go back even farther in time, Walter, even perhaps to before the birth of the Earth. Carl Sagan famously said, we are star stuff, and he didn't mean our potential to hit it big in Hollywood. He meant something else by that. Maybe you could tell me what he meant, and was it true?
Well, what he meant was that right after the beginning of the cosmos, when the Big Bang was completed, there really were only two elements of any importance at all, and that was hydrogen and helium. And we're made of a lot of other things. We have hydrogen in us, but we also have carbon, we have oxygen, we have sulfur, and lots of other things in us. And Carl's point was that those other elements were cooked up inside of stars. They were byproducts of the nuclear reactions that make stars shine. And then they got spread all over the cosmos when the stars that they were in exploded as supernovas. And so that's a really wonderful point, and that's something that big historians have picked up on. The big historians, many of whom come from a background in the humanities, they understand that we are star stuff.
Yeah, it's sobering to me to think that my innards were once the innards of a very large star somewhere, some star we don't even know about.
Mm-hmm. Let me just finish the comment about Carl's statement that we're star stuff, because to a geologist, that's not the whole story, because after a supernova explosion, all of those other elements that have been made are all mixed up, and they're all diluted. Supposing you were in a spaceship going to another star and you needed silicon to make some computer replacement parts, and you kind of put out a scoop, you wouldn't get it because the silicon is not concentrated. But what the geologists understand is that we are made of star stuff concentrated by Earth, because Earth has all sorts of physical and chemical processes that will make for concentrations of gold in one place and concentrations of carbon as coal in another place and concentrations of silicon in sand. And every one of those concentration processes is fascinating in its own right. And every deposit of metals or non-metals or anything else valuable has its own fascinating history. So what we like to say as Earth historians is that we are made of star stuff concentrated by Earth.
Well, finally then, Walter, this is a big question that to me is big history, but maybe not to everyone. If the dinosaurs hadn't been wiped out 66 million years ago, a discovery that you, of course, were involved with, would we be having this conversation? Was our existence as an intelligent species such a close-run thing that, if that asteroid had arrived an hour later and missed the Earth, there'd be dinosaurs in Berkeley?
I think that it's very likely that that would be the case. I mean, it's common for people to think of dinosaurs as something sort of outmoded and just kind of falling apart because it wasn't very well adapted. That's the common use of dinosaur as a metaphor for somebody who's outdated. But the dinosaurs were doing extremely well. And they had been the dominant large land animals on Earth for 150 million years. And it appears that there were mammals around for most or all of that time who never got very big and just ran around trying not to get stepped on. And then what you see in the rock record, which remember that's the record that we have of Earth history, what you see from the fossils is that immediately after the dinosaurs came to an end at the time of that impact in Mexico, these little mammals start becoming larger and larger. Not a single one, but over the generations, they become large. And so now we have huge mammals like whales and elephants. I think it's very likely that if it hadn't been for that impact in the extinction of dinosaurs, that dinosaurs would still be around. They might have become intelligent, and mammals might still have been breakfast.
Walter Alvarez, thank you so very much for speaking with us.
It's a pleasure. Thank you.
Walter Alvarez is professor of geology at the University of California, Berkeley, one of the founders, along with his father Luis, of the impact theory of dinosaur extinction, and the author of A Most Improbable Journey, A Big History of Our Planet and Ourselves. So talk about not taking our planet for granted.
Yes, indeed. Yeah. You're allowed to rock on, but don't take it for granted. I think everybody understands that geology must have had a big influence on, the evolution of life here. I mean, a little more water, and maybe there wouldn't be any continents, and so we'd all be fish and so forth. But to me, some of the most interesting things were the little details of geology, of really the recent past, the extent of the ice ages affecting the river system in the U.S., or rocks moving around the Mediterranean that allowed Italy to develop, things like that, gosh, they're kind of just so stories, but they're so interesting.
I like to think of us as fish doing the show.
Yeah, that's right.
Probably go along swimmingly?
Yes.
What were you going to say?
And, well, at the end, you could say fin.
The Earth's geologic features create opportunity, but also limitations for life. Up next, a new take on the disappearance of the dodo.
It's Geology is Destiny on Big Picture Science.
It's pretty amazing to think that if a rock hadn't hit our planet 66 million years ago, well, humans might never have evolved.
That's right. We take human evolution for granted. Okay, it wasn't granite that hit the Earth 66 million years ago, but it was a rock, and had it not, we wouldn't be here talking to you today.
Yeah, that's right. There might just be velociraptors prancing around the planet. And the funny thing is, there actually are velociraptors here, like the ones who help fund science radio shows.
That's right, because although that's an odd thing that Seth just said, Velociraptor is a level of Patreon support for Big Picture Science. Big Picture Science listeners who donate on Patreon can choose to be a Velociraptor, which gets them access to exclusive polling, exclusive bonus material, and thanks in the credit of our podcast.
And you can always upgrade to dolphin status if you prefer remaining a mammal and you can bounce inflatable balls on your nose.
If that gives your life more purpose. If you join us on any level at patreon.com/bigpicturescience, you can hear episodes early and ad-free, but not pun-free.
Well, I would have missed them if they had gone. But you'll keep Big Picture Science in production, and for that, our gratitude will never go extinct.
Like the dinosaurs, because birds, technically, are dinosaurs.
Well, that's true, and I think of that every time I have fried chicken. Patreon.com/bigpicturescience.
Thanks for your support.
Thank you.
The dodo gets no respect. I mean, its name is a synonym for a silly person or a simpleton.
Hey, Dodo, look over here. Ha ha, made you look.
Supposedly earned because of the popular perception that this flightless bird's stupidity led to its quick extinction by human hunters in the mid-17th century.
Now take your average pigeon. Sure, it's a pedestrian nuisance blocking your way down the sidewalk.
Excuse me?
Oh, you want to get by?
Yes, please?
Hey, everybody. How about we let Mr. Pennyloafers here pass on the sidewalk? But first, we'll spruce it up for him real nice.
Oh, never mind. I'll go around.
But we give the pigeon grudging respect for being so adaptive to its urban surroundings.
Yeah, you'll go around.
And studies have confirmed that the pigeon is no bird brain. Pigeons can count up to 9 and identify and categorize objects.
Hey, Bob, Ted, Nancy, Earl, Frankie, Marvin, Elsie, Sonia, and One Leg. You force around the hot dog stand. The rest of yous keep watch on that ledge. Except for you, One Leg. You're excused. Go hop around that woman on the bench eating the poppy seed bagel.
And they demonstrate precise aim with parked cars. Okay, that's the pigeon. And a few years ago, it was determined that the pigeon and dove family also includes the dodo.
And now, a study of part of the dodo's skull, called the brain case, suggests that the bird was at least as smart as its relatives. The dodo was highly adaptive to its surroundings, which encompassed the island of Mauritius, east of Madagascar in the Indian Ocean. But if it was so smart, then why did the dodo go extinct?
More than one predator played a role, says Ohenia Gold, an instructor in the Department of Anatomical Studies at Stony Brook University in New York. And the bird, which had lost its ability to fly as part of its adaptation to its island environment, was not able to evolve fast enough under multiple new pressures.
The geology of the island played a part in shaping the dodo's destiny. It had nowhere else to go. Our new assessment of the dodo's smarts comes from Dr. Gold's measurements of the volume of its brain case. She used a rare skull housed at the Natural History Museum in London.
What I did was I CT scanned the skull. I infilled the brain case digitally to come up with a 3D computer model of what the brain looked like. And then I used that model to figure out the volume of the brain and compared it to that of a modern pigeon. So it's not just comparing the brain volume in a dodo to the brain volume in a pigeon, though. You have to take into account the size of the animals. So the dodo is actually a really big pigeon. It's 2 or 3 feet tall. It's pretty robust. So once you standardize for the difference in body sizes, then that's when you get this ratio that makes the dodo brain pretty much comparable to that of a pigeon for its size.
Okay, so about the IQ of a pigeon, I guess. So what do we know about the IQ of pigeons? I mean, are they really that smart? I've never seen them quote poetry.
Pigeons are not. They're about middle of the road, I'd say, for birds. We have some birds that are incredibly smart, like parrots and crows, and then we have pigeons, which everyone thinks of as these really stupid birds, but only because we're so used to seeing them everywhere. In the World Wars, they were trained to carry messages between different posts, and they're used as homing pigeons, so they can find their way around very easily. They're very trainable, so they're actually not that stupid.
Okay, but some people may wonder, how can you ever know how smart an animal was that is now extinct? I mean, the dinosaurs being an obvious example.
Yeah, that's a great question. So we can't observe them directly. So the only thing we can really do is measure the volume of their brain, see how much brain actually fills up that brain case, and compare it to their body size, compare it to close relatives, and use their brain volume as a proxy for intelligence. We can't really get at the intelligence question because we can't observe behaviors directly.
Okay, so this is something they call, I believe, the Encephalization Quotient. In other words, it's the relative size of the brain to the size of the animal. I mean, if you have a big brain in a small animal, it's probably smart. If you have a small brain in a big animal, it's probably not so smart, that kind of thing?
Exactly, yep.
It turns out that they were smarter than we thought, but, if there were still dodos walking around today, how would we know that that's a pretty smart bird? I mean, what would they do that would indicate that they were not, the dumbest birds on the island?
So if you present an animal with a new stimulus and you watch how it reacts to it, you can get an idea of what is going on in their mind. So let's say you saw a dodo running around and you wanted to see how easily frightened it is, or something of that nature. You could put a box that might spring open, like a jack-in-the-box or something like that, and see how it reacts to that sort of stimulus. And if it just runs away without any further exploration, then that seems like an automatic response without much further mental processing. Whereas if it gets startled but then comes and investigates and sort of pecks at it, smells it, checks it out a little bit further, then maybe that would be a little bit sign of further thought processes going on in there.
So the dodo has become an icon of a dumb animal, but it doesn't seem to have been so dumb. Why did whoever described the dodos call them dumb?
That's actually been sort of contended in the past couple of years. Originally, the thought was that dodos got this reputation for being dumb because humans killed them off so quickly. Mauritius, which is the island where dodos lived, was discovered in the late 1500s, and within 100 years, the dodo was extinct. Part of that is because the dodos were the largest birds on the island. They didn't have any natural predators. So when humans showed up, they weren't afraid of humans. They got herded onto the boats and used for fresh meat for sailors. Rats and pigs and other introduced animals would eat the eggs and the baby dodos. So they got wiped out really quickly, indirectly and directly, because of humans. I think that is what led to them getting this reputation, just because it was thought that if animals can't adapt to people in a short amount of time, then they're pretty dumb. Because if you're getting eaten, maybe run away from the thing. But if you're on a small island, then it's kind of hard to get away from the things that are eating not you as an adult, but also your eggs and your hatchlings.
It sounds like we're blaming them for their
Exactly.
own extinction, for what we did to them, right?
Exactly.
All right. It didn't fly, though. I mean, it is true that it couldn't get away by just flying away, right?
That's right. Yep. It was a giant extinct flightless pigeon.
Okay, and it didn't need to fly, presumably because there wasn't anything that was going to eat it until the humans showed up.
Yeah, that's right. Flying is actually really difficult, and it requires a lot of muscle activity, a lot of power, a lot of endurance. So if you don't need that, it makes a lot more sense in the grand scheme to make your life on land.
Well, Do you find other surprising anatomy for the dodo? For example, there's this curvature of its semicircular canal in the ear. I don't know whether that made it more susceptible to seasickness, but it probably didn't swim any more than it could fly. But that did apparently suggest a highly developed olfactory sense, that it could smell things, and that's not so general for birds, is it?
No, so the olfactory system in birds is usually very small. They rely more on sight than smell. So to find an expanded olfactory system in a dodo, and actually in its closest relative, the Rodriguez solitaire has the same sort of protrusion of scent region in its brain, is actually really interesting. That means that they're doing something fundamentally different from other birds and from other pigeons, in fact. They're relying more on their sense of smell, which could mean that they were rooting around in the dirt trying to find fruit or other vegetable matter, other animals to eat, and not relying so much on their eyesight.
Well, you say that it has been recently contended, in other words, maybe disputed, that they went extinct because it was dumb. What were some of the other suggestions being made here?
So the extinction cause is what's been contended. In the past, it was assumed that it was directly because humans ate all the dodos. Recently, we realized that it wasn't so much humans eating them all, more so the species they brought to Mauritius with them, like rats and pigs that were eating the eggs and the hatchlings, as well as humans eating the adults.
Well, that's a scenario that's played out elsewhere, hasn't it?
Yeah, I think anytime that humans end up on an island, many animals end up going extinct.
So maybe the dodos are no more, not because they were so tasty, but because they had to confront our pets or our vermin or whatever. What does this tell biologists? I mean, what's the significance of knowing why the dodo went extinct?
I think part of it is because as scientists, we like to know as close to the truth as we can get. So having that sorted out just pleases us as scientists, but also it helps us figure out how to conserve species on islands today. So if we know the root cause of extinctions in the past, we can try to avoid them in scenarios today as we're trying to conserve as many species as possible in these modern day extinctions that we're seeing.
Maybe you could tell me a little bit about the role of island geography, the fact that this all occurred on an island. These dodos weren't on a continent anywhere. They were on an island. And so how did that play into their extinction?
When you live on an island, there's fewer places for you to go. So if something is attacking you from one side, the furthest you can get is the other side. There's not this vast continent where you can escape to. There's no refuge for you. So because of that, and because they're flightless, I mean, they couldn't even leave the island and go somewhere else to find a place to live. They were really limited in their ability to escape humans and their introduced pets as well. So we didn't give them much option, basically.
Well, finally, Ohania, in general, what is the role of living on an island in terms of shaping evolution? No man is an island, but obviously some birds were, and they confront evolutionary challenges that we don't see on larger land masses.
Islands are actually really interesting because they will appear out of seemingly nowhere, usually underwater volcanoes, and they have these brand new habitats that are uninhabited. So when animals actually do make it onto these islands, they can adapt very quickly to these empty niches, and that makes them very adaptable, very suited for the environments that they're in, but not able to change rapidly when new threats face them.
Ohania Gold, thank you so very much for speaking with us.
Thank you for having me.
Ohania Gold is an instructor in the Department of Anatomical Sciences at Stony Brook University. Well, the dodo may not be smarter than your average bear, we don't know, but is certainly smarter than we thought it was, and smart enough, intelligent enough to adapt to its surroundings. So in the island that it lived, it knew what it needed to do. But then when new threats came along, it was stuck because there was nowhere to go.
Yeah, it was literally limited by being only on a small island. I have to also say the hubris in saying that just because we wiped them out, they must have been stupid. I mean, we haven't wiped out the housefly, and I don't consider them particularly smart, certainly not smarter than a bird like the dodo.
Well, we heard Dr. Gold say that if we knew the root cause of extinctions in the past, we could try to avoid them in scenarios today. Well, we are all island residents of Earth, and this planet is changing due to human activity. Indeed, so much so that we may be entering a new geologic era, the Anthropocene. So what is our fate when there's no other planet, no planet B, to go to?
That's next. It's Geology is Destiny on Big Picture Science. If you want to know what the weather is, we'll take a glance outside the window. But that's also a good way to figure out which geologic epoch we're presently in.
Even if it's snowing and the mercury is falling, and no matter how many snowplows you see out your window, you're not gazing upon an ice age, not a woolly mammoth in sight. They thrived during the Pleistocene, or Ice Age, when glaciers pushed down as far as the 40th parallel and a third of the Earth's surface was covered in ice.
The ice vanished, as well as a lot of hirsute tuskers, about 11,700 years ago. And we've been in the relatively balmy Holocene ever since.
But scientists now suggest that Earth has entered a new phase of geologic history, one defined by human activities. It's so distinct, it requires its own name, the Anthropocene.
Humans have left their mark on island Earth, and like the dodo, we don't yet have another island to hop to.
Earth in Human Hands is astrobiologist David Grinspoon's account of how we have changed the planet and how we might shape its and our own future.
David, the history of the planet is long. As you well know as a planetary scientist, Earth has witnessed some critical events that have shaped its trajectory: the arrival of oxygen-producing bacteria, the collision with an asteroid that wiped out 75% of life. How would you characterize the time we're in now, one that scientists say is deserving of a new name, the Anthropocene?
What's new and very strange about right now is that the planet is being changed by cognitive forces. We are the first geological force that is aware of itself. Never before has there been a geological force changing the planet that can go, oh, look at what we're doing. And the promise of that, of course, is that then you can say, oh, should we keep doing this? Or maybe we don't like the way this is going. We can change course. The cyanobacteria, I don't think, had that option when they polluted the atmosphere with oxygen.
They weren't aware of the fact they were going to kill a lot of things.
No. And that in itself won't necessarily save us, but it gives us the potential to behave in a different way.
Well, this moment of our geological age is therefore called the Anthropocene. Anthro, in Greek, of course, refers to humans. Geologists say that we're moving out of the Holocene, which is what we're in now, and entering into the Anthropocene. What exactly defines this new geologic era if you had to write it down into a textbook?
Well, there's a debate about that now, when exactly it starts. And for some of us, that doesn't really matter. We can say, well, it's here, we're changing the planet. That's actually kind of obvious if you look at the numbers of how the hydrological cycle's changing, how the atmosphere is changing, all these indicators. But the stratigraphers, the people who define the geological timescale, they want an actual moment. They want a layer in the strata where they can put their golden spike and say, here's when it begins. So that's led to kind of an interesting debate. Some people think it ought to be the horizon of radioactive isotopes left over from the first nuclear bomb tests. Some people think it ought to be the signature of when carbon dioxide started going up in the atmosphere from the Industrial Revolution. Some people think it should be 7,000 years ago when we first changed the climate by clearing enough land for crops so that changed the atmosphere. So it's been a kind of feisty debate. And my view is I don't really care when they decide the actual start date is. I find the debate interesting because it's sort of, if you look at all those potential beginning times as a set, it's kind of a narration of the encroachment of humans on the planet and all the major steps we've taken.
I would think maybe the appearance in the sedimentary layers being dug up 100 million years from now, of aluminum tab tops, because they'll survive, right?
And Twinkie wrappers and Twinkies themselves will probably survive.
Okay, well, you're a planetary scientist. You compare the story of Earth to that of other planets. What kind of perspective does that give you? Because they obviously don't have an Anthropocene.
Yeah. Well, so my two favorite planets to compare Earth to are Venus and Mars, the neighbors that flank us on either side. And you go back to the very early days when all three planets were spanking new baby planets. And as far as we can tell, they were all very similar in their environments. And these three planets all went through catastrophic changes. Mars lost its water and froze. Venus lost its water and broiled. And Earth went through the catastrophe of the origin of life. And it may be strange to call that a catastrophe, but in terms of the scientific meaning of that term, which is just a radical change in state. And then a lot of things happened. Obviously, fast forward to now, and I think there's another transition going on that in some ways may be as important in planetary history as the origin of life, which is kind of an audacious thing to say, but it's a radical transformation in the relationship between the planet and life to have cognitive systems suddenly take over and become a planetary system. And so the interesting question is, can this last? Is this just going to be a blip and with that layer of pull tabs and Twinkie wrappers? Or is this actually the beginning of a phase, perhaps for the rest of the history of the planet, when cognition and awareness are part of how the planet operates? To the very early days, and of course that depends a lot on to what extent we get our act together over the next few centuries.
Yeah, but still, that's all pretty short time scale. I mean, yes, Venus went bad. Venus is a particular interest of yours, but it didn't go bad over the course of 10,000 years or anything like that. I mean, 10,000 years in the geologic record is it's a width of a human hair. I don't know what it is, but it's pretty short.
Yeah, it's really short. It's practically instantaneous, and that's some geologists, that's the basis on which they object to this notion that we've entered a new phase, the Anthropocene. They say, well, but it's too short. How can that be a geological time? And yet, from another point of view, that's part of what's so shocking about these changes is that nearly every cycle, all the geochemical cycles of Earth, the carbon cycle, the nitrogen cycle, the sulfur cycle, and the water cycle, and the climate, all these things are really perturbed in a dramatic way and in such a short time scale. So depending on how you look at it, it's so short, it's not really a geological event, or the fact that it's so short and so dramatic makes it an extreme geological event.
You look at the geologic history of Earth, obviously, and mass extinctions are part of that history. What makes you say that we're in an extinction level event today?
Well, the rate at which species are disappearing from the planet right now, almost completely due to our activities and habitat loss, climate change, destruction of a land for agriculture and so forth, the rate of that loss is on course for a mass extinction. We haven't caused a mass extinction yet, but if you compare the rate at which species are being lost now to the beginning phases of some of those mass extinctions, and if you project it, another couple centuries into the future, then it would quantitatively be a mass extinction.
Now, one thing that is noticed by maybe not so much geologists as zoologists, biologists, is that if you have an island ecology, things can go bad very quickly because you don't have, the options to, if you will, diversify either where you're living or your species or something like that. And here we are, Earth, it's probably the best place to be in the solar system, all deference to Venus and so forth. And maybe it's the best place to be in this part of the galaxy. Who knows? There's no planet B that we know of. Maybe there's not enough time for us to evolve and solve this problem. What do you think?
Well, I think that we are going to solve this problem, and there's time, but it's a question of how much pain are we going to cause? How difficult is it going to be? Think about the fact there's going to be a 22nd and a 23rd century. We won't be using fossil fuels. Even if we are the dumbest we could be, we won't be using fossil fuels by the 23rd century because there won't be any left. And population is going to level out and actually level off and start to decline. All projections show this, probably later in this century. Now the question is, what's it going to look like, the path between here and there? We can do this the easy way or we could do this the hard way. And the way I look at it is that if we do this in the wrong way, the 21st century could be as bad as the 20th century. And when I say that, people say, what are you talking about? The 20th century was great. Mm-hmm. But actually, if you consider the 100 million people or so that died in famines and wars, it wasn't all that great. And I think we're looking at that scale of tragedy if we don't get our act together. But we are going to get through this, and there will be a world. And in my view, sometime by the 22nd century, we'll probably be removing carbon dioxide from the atmosphere and starting to repair some of the damage that we've done now. And we'll look back on this time and say, can you believe that we were that stupid and we were driving around in these primitive cars? What were we thinking?
You're right that Homo sapiens has dodged extinction events in the past on the basis of ingenuity, if nothing else. Maybe you could give a few examples of what we've done in the past.
Yeah, one thing that gives me hope is that I see that we have the capacity, in a sense, to reinvent ourselves. That's what we're talking about, to find a new relationship between our species and the world. And we've done this before when we faced existential crises. There have been a few times when the human species was almost wiped out. Famously, at least among, paleobiologists, 190,000 years ago, there was some kind of a genetic bottleneck where it looks as though the human species was almost wiped out and then repopulated from, perhaps just something like 1,000 people. Really almost all gone. And
is that why we all look the same now?
Well, actually, it is why human beings have a very low genetic diversity. Compared to some other mammalian species, we are all very, very closely related. And it is because we re-radiated from this time when almost all of us were gone. And one idea that is supported by some field work that some paleontologists have done is that there was a place in southern Africa on the coast called Pinnacle Point, where there's a site with some fossils and some artifacts, where we were hunter-gatherers. And we couldn't be hunter-gatherers anymore because there was climate change and there was an ice age and the game that disappeared. And so most people died out. But this group of people living on the coast figured out how to dive for shellfish, and they invented new technology that required new levels of cooperation and language. And some people believe that that was the birth of modern humans. Out of this crisis, they found a new way to work together and invented new technology and found a new way to live. And we've done that before. And it's through our ability to work in groups and use our imagination to solve problems and find new solutions when it seems as though there are none. That's how we've survived before. And in a certain sense, in an enlarged way, I think that's our challenge now. We're very good at local survival problems, at solving local survival problems, but we've never really grappled with ourselves as a global entity. And that's what we have to do now. We have to sort of enlarge our conception of ourselves and learn to act globally.
We're talking about the Anthropocene. That's rather self-referential. But one thing that might happen even in less time than the 10,000 years we've been talking about is that we invent our successors, some sort of machines, and we're taking the anthro out of the Anthropocene, and maybe we'll soon be entering, the machinocene. Any thoughts on that?
Yeah, could be. Some people do object to this word Anthropocene, not just because it might be machines, but because it seems very self-aggrandizing. Other species don't get a geological age named after them. Why do we? And, does that serve this sort of human-centered, egotistical view? And maybe it does, but I actually think it's a healthy thing to acknowledge the level of the effect that we're having on the planet, and that maybe it's actually a step towards accepting responsibility to say, yep, objectively, if you look at what's happening, it's us. But will it continue to be us is an interesting question. And I introduce a different term in my book, Earth in Human Hands. I say that this could be the beginning of the Sapiozoic Eon, and that planets may have Sapiozoic eons, meaning, and that's also sort of an aspirational term because that means wisdom, just like we're called Homo sapiens. Are we really wise apes? Well, it's a nice thought. So Sapiozoic would be the eon of geological history in which a planet is sustainably and wisely managed. And it doesn't refer specifically to us. It's not necessarily the Anthropocene, because that way I can talk about a Sapiozoic on other planets where extraterrestrials have achieved this. And in fact, there could be a Sapiozoic on Earth that is not human beings. It could be our machine descendants, or if we really blow it, it could be, the crows or the honeybees or the termites or the meerkats or whoever in the future gets a little bit smarter and learns how to use technology and build a civilization.
David Grinspoon, thanks so very much for speaking with us.
Oh, thanks a lot for having me on. Always a good time.
David Grinspoon is an astrobiologist at the Planetary Science Institute. His book is Earth in Human Hands, Shaping Our Planet's Future.
Well, what we've heard in the show is that even though we have the hubris to think that where we are, our society, our culture, our species, is the result largely of our own efforts, our own volition, in fact, there's always geology setting the stage, controlling things. It's like a puppeteer. It's been in charge for a long time.
And as Walter Alvarez said, it's been shaping human history since the early universe and through the Ice Age and up to the development of civilization. And any island species knows that an isolated bit of land comes with opportunities but also limitations. Just ask the dodo.
Yeah, and the hope is that we don't become something analogous to the dodo because we're on this island called Earth. In fact, that reminds me of a film, This Island Earth.
But the difference is that the dodo did not change its habitat. It didn't modify its habitat, its island habitat, and we are modifying ours.
Exactly. And what's interesting here, what we hear from David Grinspoon, is that, for the first time in history, in a sense, we're kind of replacing geology as the driver of everything that happens here on Earth with our own efforts. It's the Anthropocene, because geology, generally speaking, works rather slowly. Think of tectonic plates or ice ages coming and going and so forth. And here we are doing things in a matter of decades, centuries, and so forth that can, in fact, greatly change the future. This is something totally unprecedented.
Well, do you think the Anthropocene will be the last geologic epoch?
Well, that assumes that we last forever. I don't know. Maybe if we invent machine intelligence, the machines take over the Earth and, we kind of die out. And then the machines decide that, they like trees and parks and so on. And we go back in time a little bit. I don't know. It's hard to believe that we will define the last geologic era of this planet.
Yes, you did mention that to David Grinspoon, didn't you? The Machinocene.
The Machinocene. Yeah, that's right. I mean, look, Earth has another, frankly, another 5 billion years to go before, it's really obliterated. So there are going to be other scenes, and we're not going to make those scenes, but something will happen.
We might cause a scene.
Yes.
Thanks to the rock stars who helped us produce this show, senior producer Gary Niederhoff and intern Sarah McQuaid.
Thanks also to financial support from Rena Shulsky David and Sammy David, and to the William K. Bowes Jr. Foundation. Big Picture Science is produced at the SETI Institute, a nonprofit scientific and education organization whose scientists study the origin and nature of life, including the importance of plate tectonics in maintaining our atmosphere. Oh, and a big thanks also to our listeners and Patreon supporters.
Your ears have been attuned to the Big Picture Science episode, Geology is Destiny, which originally aired in 2017. Since then, an actual geologist, Sarah Derwin, has joined us, and she had some feedback, Seth, on your interview with David Grinspoon about our new age we may be entering. She says that Anthropocene is the preferred pronunciation rather than Anthropocene.
Well, I got to tell you, Molly, I've since asked David Grinspoon, and he says either is fine. In fact, he pronounced it both ways during our interview.
I think he did that to accommodate your pronunciation, which was Anthropocene.
Well, I guess you shouldn't take me as a model indeed. But anyway, if you'd like to hear more etymological squabbles, check out the Big Picture Science archives at bigpicturescience.org.
You'll also find links there to the guests you heard.
Hey, are you going to the Million Pigeon March in Trafalgar Square?
Nah, I'm gonna join my local chapter in Central Park.